Mayor. We have started, yeah.
Okay. All right, thanks, Nick. Yep, Steve Pearson, I'm from Technical Authority, previously Wales and Western, and I'm going to talk about unattended geometry measurement systems, principally with a Wales and Western angle to it, but also a bit about the wider outlook as well. So what we'll be covering. So I'm going to split the talk into these sections, talk about some different things. I'm going to talk about the particular differences between the attended system and unattended, which you may be aware of, but just to think about it a bit more. Some bits about governance and validation of a UGMS fitted train. What we're doing on Wales and Western, how we're getting on with the fitments on the fleets at the moment. The stages that I envisaged we're going to go through to achieve implementation of UGMS. How the intelligence and benefit, how intelligence has been garnered so far, where we're going so far, what benefits we're going to be reaping from the data we've had so far. A couple of the key challenges that are emerging from how we've been, our experiences over the past year or so on Wales and Western. And then about where UGMS is going, what we're going to do next from a tactical perspective, and then the wider horizon as well. So I will move on. So the first bit I want to talk about is just the differences between the systems. So an attended system, and I'll keep referring it to as a yellow train for ease of reference. A yellow train has individuals sat on it, an on-train technician, and they can fulfill various activities. They can do some basic maintenance on the vehicles. They can make sure that the data is flowing correctly from the vehicles during the recording, make adjustments if necessary. And they can be very useful if you've got the train is routed off route for some reason, an operational issue, which means that the train isn't going where you expect it to do. So they can make adjustments at that point. So there's an inbuilt quality control system on the data that's coming off the train at that point, dealt with in real time. The data is then moved to Insight. So Insight, if you're not aware, is Network Rail's tool for managing track quality and managing the defects that arise as track quality. Typically intervention level faults, level 2 faults, you might know it as. So it provides a format for some basic data processing and then management of those data, management of that defect. So that system will be viewed by the teams in the depots and the delivery units, work plans compiled, and works take place on site. All fairly straightforward. It's an established process, been there for many years. Within that, there is the section that the other duty that the on-train technician might do is call in immediate action faults. So if they go over a particularly bad twist or something else that needs an immediate mitigating action, then there's somebody on the train who can make the call very quickly in a timescale measured in minutes rather than hours or days, for example. You can make a call to the signalling control center or the signaler at the relevant location. They know where they are, they know who to call. And that takes place immediately, and then some work follows. So obviously, if it's an unattended system, those people are not there. So I'm going to park there for the moment, and we'll come back to that point later in the presentation. So that's the normal data flow for an attended system. So what happens with an unattended system? So an unattended system is, by definition, fitted to a train, and it's not got someone who can give that overview and control over it in a day-to-day basis. So the data flows from the train to a land-based system somewhere, and the data transmission can vary about the tools used. Principally, most of the data at the moment is used over the mobile phone network. So on the train, there is some basic processing, locational information, pulled together, batched, sent over a mobile phone network, and received at a land station, we'll call it. So at that point, there needs to be some data validation. And this process of data validation, again, I'll come back to later, but it needs to be rigorous, because before that data gets ingested into the Insight tool, we need to be very comfortable that it's of good quality. It's what we expect. There's and no errors in it, because if we put errors in it, it's kind of too late then. As in any system, you need the good data to go in order to draw good intelligence out. So that process of data validation is very important. So unattended geometry measurement system on a train was a picture of a passenger train. It should also, we also need to remember that Network Rail has its own fleet of vehicles which fall into this category as well. So that's a picture of a class 153 unit, which is currently one of the in favour type tools within Network Rail as a platform for carrying various equipment, including track geometry equipment. It's got a crew on the train, but it's not an on-train technician crew as such. They are there to monitor the operation of the train itself rather than the system. So the system is an unattended system. So it needs to go exactly the same process. We need exactly the same controls over that system before it goes into insight and before it reaches the teams to looking at work arising and planning work accordingly. So I'm talking about both Network Rail UGMS systems and TOC UGMS systems, train operator UGMS system. Okay, let's think about the measurement systems and some of the governance that we might need. So the governance of track recording systems is managed through a Network Rail standard 042, which is aligned very closely to a European standard EN 13848. These are specifying the requirements of the recording, what parameters we need to take. So I've picked out a couple of aspects from that standard to think about here. So one is the primary and secondary parameters. So the standard lists primary parameters, which the vehicle will record. So these are directly recorded elements that the system, whichever system we choose, and there are various systems, unattended and attended, that we could use here, but they all need to meet this criteria as far as the parameters that are being measured. And then from those primary parameters, you can deduce by calculation secondary parameters as well, which you'll recognize if you're involved in track maintenance. So you'll see that there are some speeds in there as well about the speed of the vehicle, and I'll come back to this again as a theme. So the standard recognizes that some systems struggle when the speed gets low because of the way the vehicle is behaving, and it impedes the data collection. So there are some limits and expectation that if the speed drops below a certain point, then sometimes the data streams start becoming unreliable. So that's one of the factors we need to think about in how UGMS might play a role. The other element is repeatability, and there are tolerances for each of the parameters that the vehicle is measuring, and we need to be confident that the vehicles are picking up their information in a clear and consistent way within the tolerances specified here before we ingest it. So that's part of the gatekeeper sort of work that we would do to bring it into before it brings it into insight. Okay, so that's primary and secondary parameters. The other thing that the standard talks about is primary and secondary systems. So a primary system, primary TGR, track geometry recording system, is one which has a dedicated vehicle. So we're talking yellow trains here, like the new measurement train, and it goes through a verification process in order to carry out its calibration. So this is a more detailed process on a clearly defined test track, and we can measure and verify and calibrate the train at that point. And it goes through that as an annual activity to set the standard, and then it carries on that for another year before it gets calibrated again. The secondary system is different. So we're talking about secondary TGR systems like UGMS, where there's an in-service vehicle, and we need to have a different way of calibrating that vehicle. It wouldn't be realistic to send it to the same track, a fixed track of some kind every time, every year. the vehicles are obviously revenue earning and we need them to be out and about as much as possible. That's fine, and if actually, I'll argue shortly, I think it's actually better. So what we've come up with is a virtual test track. I'll talk a bit about that in a minute. So that's how we would manage a secondary track geometry recording system. So a bit more on that, the virtual test track. So we do train validation through UGMS system on a virtual test track. We need to identify a suitable element, a suitable part of the infrastructure to use as a test track. We need a section of railway which has got some good and some not good track quality to test the system properly. Reverse curves is one of the features we want to be able to see regularly. High cant, not defined high as such, but it needs to be some significant cant. So it gives an opportunity for testing the sections. And a section which has got some variable speed running is good. So a station or a low PSR section is good because it enables you to test the vehicle's recording system at different speeds. So with the work we've done on Wales and Western, we've used, if you're local, you'll know the section between Unattended and Swindon. So it's around 10 miles or so of the main line. So it's 125 mile an hour main line, 2-track railway on various configurations. It fits all those characteristics, including Swindon Station. So you've got a slow section coming into a station. So the method is that that you're going to run the test train that you're trying to test, the UGMS train, over this virtual test track, and then you're going to calibrate it against a yellow train, which you're also going to run over the same track. And there's a calibration between the two, a test between the two broadly to make sure that they're aligning. The trains operate at different speeds, and also we want the train to operate at different orientations as well to turn the train around. If it's likely to do so, and again that's a factor on Wales and Western, because there's one diagram which goes to Cheltenham at the end of the day and it goes around Gloucester Triangle, so the trains turn around. So we need to be able to operate the trains in both directions. If you had a fixed network where it just goes up and down, East Coast Main Line as an example, because they always put first class towards London, then you don't need to worry about the different orientations so much, because you're going to be clear, you're only going to take valid data when it's operating in that orientation. So we do the operation over the virtual test track, we do run-on-run comparisons, and it becomes very much a statistical exercise. So the report that is compiled to support that the UGMS system is operating correctly and is calibrated correctly. If you look at the pack, it's like 60 pages of graphics like that one there with bell curves and things, outliers. It's all statistics to show that the bulk of the data, where it's fitting, how are we dealing with outliers, and it's very much a statistical exercise rather than an engineering exercise. So just thinking a bit more about the train operation on the test track. So the features that you're going to be looking for in carrying out the validation are these. The first is comparability. So you're going to be comparing between the trains. So we've got the opportunity to compare not only between a UGMS train and a yellow train, but different UGMS trains, because there's several now. So we can compare between trains, and we can look at different orientations of the trains, and we can look at some variability of speed, because our test track includes some slow section. So that's the graphic on the top left. The graphic on the left and the bottom is reproducibility. So this is looking at the same train, but swapping it around at different speeds. Are you being able to reduce the same measurements for that piece of track, regardless of the orientation and speed of the train? That's one of the important things. And the other is repeatability, running the same train, same orientation, same speed. Does it all the time give you a consistent result, which give you confidence in the level of detail that it's providing? The other feature that we will look at is fault count as well. So setting a threshold. Is the UGMS system, the secondary system, giving you a similar fault count, similar number of threshold breaches to a measurement train? And if it's not, can you explain why not? And there are some good reasons, engineering-wise, why it might be slightly different, but as long as you understand the difference, you can articulate what the problem is, and then you can identify whether your calibration is good enough or not. So that's fault counting there as well. Put an about there about the other thing is in this is about the opportunity for future continuous assurance. I mentioned that the yellow trains go to a location and are calibrated through once a year. Well, UGMS operates with several trains with running now. So I believe there's an opportunity here, and actually we're going to challenge the European standard, which talks about annual calibration. I think there's a better option here, which is some continuous assurance looking at all the trains. So if I've got 5 trains running up and down the same piece of track every day, I'm going to spot the one which is going out of calibration because it will start to sway away from the others 4 generally. And that will be the one that you'll be focusing on. So it gives us an opportunity to move away from an annual calibration, which feels a bit outdated, into some sort of more continuous assurance. So I think that's one of the opportunities which UGMS is going to bring us. So that's the validation of the trains. So how are we doing on that? So in Great Western at the moment, we've got trains, we've got UGMS fitted to 5 trains, and that's 5 trains which are now validated. They've all been through this process. They've all been through the test track, a statistical report compiled, and the calibration is good. So I've got 5 trains running up and down now, which are all validated. There's one other in the process of being validation. It's been fitted. It's all running good. We're just compiling the report. And there are another 2 which are in the process of being fitted. So we're going to have a lot of data available to us now from these trains. And there's some details there about the numbers of the trains. If you want to go out and spot a UGMS fitted train, there's numbers and the date when they were signed off. So it's an ongoing process. So that's where we are on GWR fleet fitment. So I've talked about validation. So now we've got some trains up and running. So the important thing is how we're going to use the data. UGMS is not new in the UK. And I had a conversation with somebody only yesterday who said, oh yeah, we were doing this 10 years ago. We were. This data was available on the Chilterns 10 years ago. But the application of the data is the thing, and I'm determined we're going to make a difference this time. So I'm seeing the application of UGMS data and implementation of it in 3 stages. So the first stage is in a complementary way, where we've got a yellow train, which is giving us our compliant, safety critical way of managing the infrastructure. And we've got some UGMS trains, which are going to give us complementary information, and we can use that in an ad hoc and tactical way to support the way that we're managing the safety critical elements. So that's kind of where we are at the moment. And the graphic on the top right is an illustration of the supplier's system, which visualizes the data coming off the UGMS trains. So it's a standalone system. It's not within the safety critical management way insight system at the moment. So it's complementary. So that's stage 1. Stage 2 is supplementary, where it can be supplement or replace a yellow train. So there could be locations where we don't have what we would judge an optimal frequency of measurement with the yellow train, and we could supplement the yellow train recordings with UGMS information. That's be one, so it could supplement. And the other thing is, if the yellow train is recording has failed for whatever reason, system failure, traction failure, operational incident, whatever the reason, could we substitute in UGMS data? And by the substitution and supplementary, I mean treat the data in exactly the same way as we would a yellow train. So it goes into Insight. It's indistinguishable from whether it's come from a yellow train or from a UGMS train, as far as the final user is concerned. So that's where I want to get to for stage 2. A bit more about that, about the next thing to come. And stage 3, I still see stage 3 as a risk-based maintenance improvement. So I've called it next generation risk-based maintenance. So risk-based maintenance has been around as a technique in network rail now for similarly about 10 years, actually. It's based on P to F curves for an asset mode of failure, where it says, well, this failure mode can occur, and the first indication of it is a point P that you can measure on the curve, and then you can track it down to its failure. So the point Ps that we've been tending to use on track are an alert limit fault detected by a track geometry recording train. And the time it takes to get from the point P to the point F is deduced by some people used to who are technical experts, some that are used to maintaining the piece of track that you're talking about, and a time scale is deduced based on experience and knowledge on what they're talking about. So that's served us well for where we've been operating risk-based maintenance. But I think the next phase would be to have a UGMS data stream at high frequency, which can help track down that curve. So you can identify a failure or a potential failure and track it down the curve with some accuracy. The existing RBM regime assumes that if it's the same line speed, the same tonnage, and same traffic characteristics, then it will follow the same curve. But I would contend, well, why would it? You can have a wet bed at 10 miles and a wet bed at 10.5 miles on the same piece of track. It's different configuration. There'll be different drainage elements to it, different construction to it. It may well vary in a different, deteriorate in a different way. So UGMS offers the opportunity with some intelligence to say, well, that fault there is deteriorating at this rate, that fault there is deteriorating slightly faster, you need to move quicker, or it's slightly slower, you don't need to move so quick. So I think that's the next phase of risk-based maintenance that UGMS can offer us. Okay, so where are we at the moment? So at the moment we are at stage 1. We've got 5 trains operating at the moment, and we are realizing some benefits, and these are the key areas that we're using at the moment. The first one is validation of cyclic top repairs. So we've done some work in looking at the data that's coming off the trains. We've applied some tolerances around to account for some variabilities of this area. And we've got a method now where we can use UGMS data to validate that a cyclic top repair has been successful after its consolidation period. The cyclic top has got reoccurred and the speed can be removed. So why would you want to do that? You might want to do that because the timing of your yellow train run might not coincide with when you did the work, and it's not great business to be sat around with a cyclic top speed waiting for a yellow train to verify what you think is probably a good repair. So this offers the opportunity to accelerate it. And we've applied this 5 times, I think it is now, on Wales Western, on specific sites, and accelerated the removal of a cyclic top mitigating speed. So that's the benefit. Verifying the resilience of repairs is another one. So if you carried out a repair, you want the repair to be resilient and last. Typically, we've managed that by looking at repeat failures, how often repeat failures occurred, but this offers a next layer of granularity to say, how effective has that repair been? Has it started to go off quick? And I know if one of you online is still there, there's been even a bit of competition between section managers using this data to say, well, my resilience is pretty good. Your resilience isn't so good. So there's a bit of opportunity there to use this data in a different sort of way. Assisting with incident investigation or failure modes is another method, and we've been looking at it in terms of some of the failures that we've had. There was a broken rail on the main line last week, so this data has played a part in looking at what that looked like when that occurred. Could we have seen other precursors and should have responded to it? So I think that's a development area. So all of this is contributing to our learning and supporting a business case as well, which is another theme about how we pay for this kit. The fourth one I got is about renewal sites. So where you have a line speed opening or a high speed opening on a renewal site, where you've got some reballasting or formation work. So the way that site is consolidated, you can mitigate it by using the dynamic track stabilizer, for example, but there's still an element of unknown there. You can bring that unknown element down through good design, good implementation, quality control during construction, but at the end of the day, it will still behave in a slightly unknown way under train. So the way that you could assure yourself that you've got that under control and give you more confidence to increase a line to get to a line speed opening would be from frequent measurements. So that's currently done in a manual way, which isn't great because dynamic measurement's always better than static. So UGMS can offer that. And we've got a couple of sites in Wales and Western coming up in this year's programme. We're going to try and use UGMS for the first time on that to give us assurance about high-speed opening. So that's where we are. The fifth one I've got is temporary variations. If there's a temporary variation needed or discussed or proposed in relation to a lost recording, it can give you a mitigation. It can't replace it at the moment in stage 1. Might do one day, but not at the moment. Soil moisture deficit is a risk in the southeast of England on clay formations, clay embankments, which can dry out and move quite quickly, depending on the soil moisture, and a higher frequency of recording can give you some foresight or insight into that as well. And it's worth noting that it's not only track as well that could benefit from UGMS. Besides the soil moisture deficit in embankments, for example, so it could give you some information on any type of embankment failure or the likelihood or if something's arising. And I was talking to a colleague only the other day about problems with one of the culverts, and so by using UGMS data, it gives you another layer of mitigation that there's nothing untoward coming. So that's where we are. We're at stage 1 at the moment, and some of this stuff is happening daily now. I've checked it with Western Route in particular, and the data is being used daily. So there is some benefits coming through now. Bit about emerging challenges. So one of the emerging challenges is data dropout. So that's a graphic of one of the it happens to be a twist, and you can see there's gaps in the trace. So why is there gaps in the trace, and does it matter that there's gaps in the trace is a question as well. But slow recording speed could be one if it's dropped out, but that's probably not the case on this one because it goes in and out. A data transmission could be an issue. I've said about the way it's batched on the train and transmitted. Sometimes the way the batching happens can affect some of the data flow. But the predominant cause is dirty optics on the system. The systems on UGMS are typically optical systems. So they rely on a clean vision camera and a laser system, which is highlighting where the rail edge is. And that, if it's not clean, that can influence just the moving in and out. So that's one of the challenges, because as I said, if you had an on-train technician, they'd be able to carry out some basic maintenance, literally cleaning the equipment before the start of the shift, but that's not possible with a UGMS kit fitted to a train operator's fleet. And indeed, the basic maintenance needs to be part of the train operator's maintenance regime. So that's an added complication as far as some of the fleets we've got at the moment. So thinking this is a bit of a busy slide from some of my Insight colleagues, but just thinking about a couple of the factors that we're dealing with in there. So I mentioned about the validation of the data before it goes into Insight. Sounds relatively simple. It is relatively complicated, actually. There's some issues with it. Location is an issue. The systems, the yellow trains operate with the equivalent of route setting tapes. It knows where it's going, and the system knows to expect it. A passenger train is operating on a different regime. My colleagues have coined the term Frankenstein file. So the graphic on the top right shows rows of data and the geographical location on the columns, and a color code which says, was the data missing? Was it there but rubbish? Was it there but a bit iffy? Was it there and sound? And so one of the challenges is to pick the different sections out and to to create a file with all the relevant bits so that you've got good data going in. So that's been quite an effort. We need a method of carrying out that validation. UGMS versus the CDMS. CDMS is the current legacy system which manages the data flow. So I mentioned about the data flow. We're looking at some of the accuracy between the systems. We're looking at the statistics between the systems as we gain more information, more data. And it's showing favourable conditions at the moment that we appear to be running. We're in the right area. That the data is good and the tolerances are being achieved and the errors are relatively low. There's some things in that. So looking at that in a bit more detail and moving on to the next generation risk-based maintenance I was kind of talking about. So a couple of graphics there. The one on the left but they're both timeline graphics with one of the measurement parameters. I think it's top on this one. So the top graphics show the frequency that you get from a yellow train, typically 4 weekly. And then there's a little blue section, which is the part where we've looked at some UGMS data. And then the bottom graphic is the blue part exploded out. So you can see the data. So there's some differences on some of the overall numbers, but the gist is that the one on the left shows pretty good correlation between the two. So that's sound. The one on the right shows that there was some variance and a big jump with a couple of recordings at that time. So what is that? Is that an indication that we've missed something or something's happened in between the yellow trains runs? Was it a data issue and we shouldn't have allowed it to go in and the gatekeeper system's not quite working properly? So this is the sort of thing we need to get into in looking at the data and how we might ingest it. The next one is about the cyclic top situation, and this slide is describing some AI type tools which we're trying to use to inform cyclic top. So cyclic top is quite a difficult measure because it measures the buildup of energy through successive dips in the track. The way we measure it at the moment using a threshold basis means that sometimes the dips can almost be breaking the threshold. Some of them may be breaking the threshold, but not enough to trigger a cyclic top response. And the output of that means that every so often you get one which just triggers over the threshold, the others are already at the threshold, the peaks, and it suddenly becomes an urgent defect. So urgent it needs an emergency speed restriction applied because of mitigating to operate for mitigate risk of freight train derailments in particular. So that's not good. Unpredictable faults like that are not good for business. They're not good for safety. And the way we measure it on this threshold basis is what's doing it. So an opportunity that we're looking at now is to look at it more as a section and try to give some pre-warning of where the overall site is going rather than individual peaks within the cyclic top site. So it's an opportunity, another opportunity which we're looking at with the intelligent infrastructure team within Network Rail. So that's where we are at the moment. So what's next? So we're going to crack on with the planned fitments. As I said, we've got another 3 to go on Wales and Western. I said and beyond as well. So there are other fleets being fitted as well. So this is Wales and Western we've been talking about, but there is now 1 validated train on East Coast. There are 5 more on East Coast to come, and there are 2 on Transpennine also, which are in progress as well. So we're going to press on with all of those. And there are other fleets around as well with different systems as well. I was talking to Merseyrail the other day. We have regular calls with Avanti as well on West Coast. So there are other systems which are getting there. So we're going to crack on with that. We need to refine the operation and maintenance regimes. I talked about the dirty lenses. We need to make sure that that's good and the optics are managed sound. And we'll eventually get to looking at coverage. I've not talked about coverage. The trains just run where the trains run. Because of the number of trains, it means we've had we get a good data frequency, and it's not uncommon to have 6 to 10 runs on a track in a day because of the way the fleet operates and the fact that we've got 5 trains operating now, Wales West. So we need to develop some more of that. We need to work on the data flows, make sure the flow is taking place, the governance is in place, the gatekeeper functions are working properly. Need to press on with the stage 1 implementation business cases to develop the business case to give people the encouragement that this is worth investing in. There's an opportunity to exploit what are called complementary benefits, so such as acceleration data. So the systems that we've got fitted on the trains here have accelerometers as part of the equipment as well. And so that is providing an additional data feed, which is there now. It may not be there in the future, it's certainly there now. And so there's an opportunity to look at that, see if that's of value compared to the other geometry feeds that we get from the system. I need to prove that the engineering works for the core application, the way I described it about the P2F curve with the high frequency recordings. Is that real? Does that work? What is the optimum frequency of recordings? Data costs money to process and store. I don't want to record 6 trains a day if I don't need 6 trains a day. What is the optimum number? And then this all combines to build up a business case. So that's what's next. From a system safety point of view, on one of the earlier slides, I noted that the on-train technician calls the signaller if they find an urgent fault. So we don't have that for a UGMS. So how does urgent faults work with UGMS? The answer is we need to do a safety case to demonstrate that the overall level of risk in the system is manageable, and that the issues around guilty knowledge about a system has recorded a serious defect, but you don't know about it until hours afterwards, potentially say 48 hours. What's the system safety view on that? Is that an issue or not? And we've been doing some work over the past year trying to build up some case. We've had some temporary variations agreed so we can apply some UGMS data flow principles and build up a case to demonstrate through the common safety application of common safety method that this is a safe way of dealing with the system safety. I mentioned other fleets. So there are 2 other particular fleets on Wales and Western, which is the TFW train there and the Class 345, the Elizabeth line stop, are both fitted with UGMS kit. So I think there's some opportunity there. But just in the last couple of points, just about thinking about the bigger picture. So UGMS is a requirement in the key trains requirements, which is an IDG RSSB document, and it's also part of the DFT's train technical specification. So that means that if DFT buy a train for use in the UK network, then UGMS is one of the technologies which needs to be fitted in it. And that's been the way that the Hitachi fleet, most of which I've been talking about, is fitted. It's there for the duration of the train supply contract. So in the case of Great Western Main Line, that's until 2045. So we've got 20 years there worth of data coming off those trains, which is a committed requirement. It's in the DFT requirement. So as more trains are bought in this way, then the UGMS will expand. And finally, just about the IM program, which is something else I'm involved in my current role. So you may have seen this. It came out last Friday. New civil engineer picked up on it. We're at pre-market engagement. So the yellow train fleet, which operates infrastructure monitoring in the UK, a lot of it's based on 1960s type technology. It's unreliable. Routes and regions within Network Rail are not happy with its performance because of the poor reliability, and we can put plasters over it and do tactical approaches to try and make it more reliable, but at the end of the day it's pretty life expired and there's a limit as to how far we're going to get. So Network Rail is in the process of biting the bullet and renewing the fleet. Big project, big effect. It deals with 18 data streams, of which track geometry is one. So the question is, how does UGMS fit into this wider, bigger picture? UGMS operates on a lot of the main lines in the UK now, and the data is available now, and we need to make the data usable in the ways that I've just described, so that it can become a compliant tool. And certainly my personal wish is that UGMS forms part of the bigger picture and becomes our way of managing track quality on main lines, where UGMS, you can give high quality, high frequency information. It fits in with the existing timetable. You don't need to timetable in another measurement train for geometry. And it seems like a obvious way to bring this forward to this area. So we'll see where that goes. It's a pre-market engagement, which was the thing that came out Friday. And we'll see what the bigger picture looks like. There we go. So I'm on to any questions.
You didn't show any photos of the actual equipment. Is it a lot of black boxes and smoke and mirrors?
So I'd love to show you some pictures of the equipment. I can't show you pictures of the equipment because of the commercial deal, which I just talked about in the last slide. So it's a potential frustration because we can't stop development of this type of stuff, but there were no pictures of the kit because of that.
Yeah, okay, no, fair point. So we have got a question online. Stuart Burrows, do you want to come off mute and ask away?
Hi there. No, I just wondered if you're sharing the data with the EMP, the good doctor, just to see if you can correlate poor track geometry against poor current collection with the OLE. I just wonder if there's conversations happening.
Not less so with the UGMS data, probably, I have to say. The UGMS data is on a standalone platform, so it's a little less easy to correlate it, I guess. Obviously, we've got the height and stagger feeding into Insight now with track geometry from yellow trains. So I think it's there as a tactical issue. If something triggers a concern about it, then we could raise it. I think in the bigger picture, the OLE, the collection of data about position of OLE is part of the data streams that I just talked about in infrastructure monitoring. So how that fits in, that's more likely to fit in that way. So I think it's a good point. The data's there, but it's a tactical application at the moment.
Yeah, it's fine. It's like a backstop, isn't it? No, that makes sense. Okay, thanks, Steve.
Yeah, okay, Stuart.
Thanks, Stuart. Do we have any more? What we do in the rooms?
Yeah. Thanks, Steve. So obviously going ahead with the renewal of the yellow fleet, I think, is that also partly to get around the problem that you'd have of some loops and things like that, which would generally not have some of the passenger trains put in, and otherwise you're going to have a part of the passenger train in there that's like if out of service or against its normal operating and cope with it that way. I think.
And realistically, we're not going to suddenly shove a passenger train through a goods loop in order to carry out that recording. So the way the recording happens at the moment is that you have a mainline run and then you have a follow-up run at a lower frequency probably, which does go through all the loops.
Mm-hmm.
And so that lower frequency run that does go through all the loops will probably still be that with some sort of yellow train or other coloured train, but not a UGMS type train.
I take it then also, there's a follow-up question. That's part of the safety case to some extent. Actually, okay, if you've got the yellow train going through and it's a monitored fault, it's there. But actually, how long has that potentially been there since it was last measured? And with the unattended monitoring, you're getting it so much more frequent anyway.
Yeah.
So, okay, you get it 2 days after the test was run over it, but that's potentially weeks quicker than you would have with a monitored. I think that's part of the safety case.
Agreed, and that's one of the arguments that says, well, actually, the overall system safety we're improving for that very point. that yes, you're going to know about, even if it's 48 hours to get the train from the recording to the train data being available to a maintenance engineer who can look and act. That's probably that in some cases may well be better than what we actually achieve with a 4 weekly recording anyway. Agreed, yeah.
Yep, thank you, Steve. As usual, insightful. Just two questions. One is about using the data that's coming off UGMS to validate cyclic top speed type defects, which earlier today at TSR board in Bristol we talked about a lot in terms of can we speed up the removal of temporary speed restrictions being taken off, and you've highlighted that. But in terms of kind of following that thread of selling this or realising the business case, presumably at technical authority level and across other routes and regions, this is kind of being taken as this is a no-brainer, or is there still some pushback? Is there still more? Obviously, there's more to do technically, but what's the appetite across the business?
I think and the appetite is one of my aspirations and roles now, to build that appetite. So we're in the position where we've got the validated trains, Wales and Western, so we've got more opportunity. The Eastern train is now validated, so we have got validated train, and I'm looking forward to seeing the first real benefit on Eastern as well, which will help bring us around to this isn't just a Wales and Western opportunity. So we do need to build up, and I just need to gather evidence to do so. But yeah.
Thank you.
We don't have any further questions, so the sun's shining. I guess everybody wants to get into the garden. Thank you very much, Steve. We would do a round of applause, but it may sound feeble with the numbers. And thanks everyone for joining online. See you in 4 weeks' time.
Thank you, Steve. Thank you.